Hi all, and thanks for joining the Cloud Lunch and Learn Marathon this year. I want to thank the sponsors, Microsoft and Redgate, for making this event possible, and my session will be about PowerShell in Azure Functions. So let's get started. My name is Karel de Winter. I'm a Cloud Solution Architect working at Dexmag. I'm a member of the Tech9 user group in Belgium, and I'm recently nominated to an Azure MVP. If you want to reach out to me, you can do so on Twitter or LinkedIn, or read my blog if you will. In this session, I will give you an introduction about Azure Functions and how to use PowerShell in Azure Functions. So it's going to be a lot of fun, and I have a lot of demos packed in this session. Okay, let's start with why should you use Azure Functions. So Azure Functions is a serverless compute service that allows you to run small pieces of code, and that's what they call functions, without having to worry about the application infrastructure. So the code that you deploy to a function will be executed based on a specific event. So a function is triggered by a specific type of event. Azure Functions is a great solution to perform a particular task and to do that task as effectively as possible. So be aware that the term serverless doesn't mean that there are no servers involved. There are certainly servers involved. So, however, we could say less servers than serverless. And the responsibility for keeping those servers up and running, for patching the OS layer, scaling when needed, that's all managed by Microsoft. And this enables developers to focus on the syntax and writing code in that restricted sandbox of the serverless platform. So yes, there are restrictions like the programming language you can use, the function signatures, and input or output arguments you can define. And there are also restrictions of the amount of RAM and CPU the execution can consume, and also a timeout duration. So you have a choice of these languages. You have C#, you have F#, Java, JavaScript, Node.js, Python, TypeScript, and of course PowerShell. So Azure Functions is event-driven, and you only pay when functions has run. So that's what they call the micro billing. So what are Azure Functions? Well, when you're writing an Azure function, the core component that you're dealing with is a function app. So Azure Functions are an extension of Azure App Service. So if you want to know all about the features of Azure App Service, you can read more about that on the Microsoft Docs page. But the function app itself is your unit of deployment. And it's also your unit of development, and it's also your unit of scale. So keep in mind that a single app will be scaled as a unit. And you can have multiple functions in an app, but your app is your primary unit of development, deployment, and scale, like I said. So just think about a function as a little piece of code that can get executed when you need it. That's it. So let's get started with our first demo and create a function app based on PowerShell. Okay, for this first demo, we are going to demonstrate how you can create an Azure function based on PowerShell. So first of all, you search for the function service and then you click on new. So you can create a new function app. You choose your subscription and the resource group. You give your function a name. And here you can see that the runtime stack, you can choose .NET, Node.js, Python, Java, and of course PowerShell. So when you choose PowerShell Core, the version will be automatically number 7. You pick a region and then you click on next for hosting. So every function app will have a storage account. Operating system will only be Windows because it's a Windows-based app service plan that will be used. And here you can see that you have different plan types. So you can go for the consumption plan or the premium or the isolated app service plan itself. If you choose for the consumption plan, you will only be billed for the actual firing of the function. So we are going for the consumption plan. We will enable application insights. So we have monitoring in place. We will not have tags for this demo. And now we can just create our first function app. Now we can see that the deployment is completed and we can have a look at the resource. So as you can see, the operating system is Windows, and if we have a look at our functions, we don't have any functions yet, so we can create one, but that's basically it. So we have one function app, and here we can create different functions in it. We can have a look at the configuration. And we'll see that the functions worker runtime here is PowerShell. So that basically was it to create a first function app based on PowerShell. Okay, now that we know that a function is some piece of code, let's see how we can execute our code within our function. So that's the moment when triggers come into play. A trigger, that's an event or a specific situation that starts our code. So a trigger will pass some basic information to the code in order to run it. And when the code has completed, it has some output. And important to know here is that all of the functions will have a trigger and only one trigger. So you can see a trigger as the event source that a function is listening for and the data that will be passed in. So the trigger will let your function know that it has to execute. And every function can have only one trigger, and the service itself will automatically be listening to that source. So good to know is that you are not charged when a function is listening to something like a queue or waiting for a message to drop. You are only charged once the trigger fires and your code actually runs. So keep in mind that triggers are what cause a function to run. That's very important to know. And as we can see here, triggers can have the form of, for example, incoming HTTP requests, webhooks, creating or modifications in a storage account can also be a trigger, or for example, the arrival of a message on a queue. And another common option is the ability to invoke serverless logic on a timer. So this can be useful for writing serverless functions to perform specific time-based tasks, like for example, cleaning up old Azure resources, moving data to another storage tier, applying tags when needed. And the example on the slide here shows the event that fires the trigger. So the event here is when a file has been added to a blob storage. And once the trigger is fired, it runs the Azure function that is associated with it. And in this case, it runs some PowerShell code that outputs another file. And the output of the function is placed, like I said, on another blob storage. And that's very handy. So now that you know what triggers are, let's have a look at bindings. Well, bindings are data that you can pull in or push out of your function without having to integrate with that service directly in your code. So like in this diagram here, we bind our trigger to a specific file that has been uploaded to a blob storage. And we don't need to write code for that. We don't need to write code that creates that logic. it just works. And you can have two types of bindings. First of all, you have the input binding, and that's when data is pulled in at the start of an execution. You can have multiple input bindings if you will. And the other type of binding is the output binding. So that's data that is pushed out of an execution or pushed out after an execution. And here you can also have multiple output bindings, if you will. So bindings to a function, that's a way of connecting another resource to a function. So bindings may be connected as input bindings, but also as output bindings. Or you can have both, if you will. So let's have a look how triggers and bindings work, and let's create an event grid-based trigger demo. Okay, for our second demo, let's create a function within our function app. So we've selected the function app that we previously created. And if we go to functions, then we can add a new function, and we will be creating a new function based on an HTTP trigger. So that means that the function will run whenever it receives an HTTP request. So let's click on that and click add. Yeah, you can change the function name, if you will, and the authorization level. So for now, we are going to leave the authorization level to function. Click on add, and this will create a function within your function app. So now our first function is created, and we can see that it will have some PowerShell code that we can run. So here you have your known PowerShell that you can change, if you will, but this will be basically an HTTP trigger that will process a specific request for you. So if we want to test this, we can just click on test run, fill in our name, and then click on run, and it will have an HTTP request test for you, and the results will be in the output tab here below. So the response we get is this message, and we can see that this is the body of the message that will be created here into a parameter. The name will get from the request parameters, and then it will return the body and take that as a parameter. It's very nice that we can follow up the logs here in that log window. So let's dive a little bit deeper and go a little bit advanced. Let's create an event grid-based trigger as our second function. But before we dive into the event grid function, let me show you how you can execute the PowerShell code. So if you have a look again at our HTTP trigger first function, then we saw earlier that we have some PowerShell code here, and this is into this code sits into the run.ps1 file. So this is actually the code that will run when your function is triggered. And there is also another file, that's the function.json, and this is a configuration file, and that this file defines the behavior of the function, and a behavior can be how it gets triggered, what authorization is required, and what input or output bindings are defined. And this example defines, as you know, an HTTP binding named request, and an HTTP out binding named response. So this is how the code gets run from here, and how you can use those parameters. So for our more advanced example, what we want to do is that our function wants to, for example, read, modify, or maybe even delete resources within our Azure subscription. And by default, the functions you create do not have those permissions to manage any of your Azure resources. And whether that be in the same or separate subscription where the Azure function is. And for that, we are going to configure a managed identity and also setting some role-based access control. So the function app, and therefore all the functions within that function app will have the permission to manipulate the resources that we want to that we want to provide the managed identity access to. So for that, we have to go to the function app itself, and then we go to identity and we select a system assigned identity. We click on the on status, we save, and it will say that it will register the system assigned managed identity, so it will create an app in Azure Active Directory, and then we can grant that managed identity access to resources. And what we will do is we will give that managed identity access to our subscription, so we can have all things that we can do with that. So let me just grab that object ID. It's now hidden, but you will see it here. So I'm going to run a PowerShell command that will have a new AZ role assignment with my object ID, and that object ID is my managed identity. And then I have the contributor role, and I will scope that to my subscription. So for that, we now have system assigned managed identity with contributor rights on the subscription. Okay, now we will create another function, and it will be an event grid function. And the function will leverage the access from the newly assigned role that we did in the previous step. And it will take that and use that to modify an Azure resource directly. So the function will look for when a new resource group is created, and based on the value of a tag named environment, will then add another tag to the resource group named cost center. And that will have an appropriate value. Either it's value A for development and value B for a tag with environment production, for example. So what we will do is we will create our second function, and that function will be based not an HTTP trigger, but it will be an event grid trigger. We give it a name, for example, cost center, and then we click on add. So you will see that a second function within our function app will be created, just like the HTTP trigger. And here we can have a look at the integration. Then we will see that it has no inputs, it has no outputs, it just has one function, and that's the cost center that we just created. And the trigger will be an event grid trigger. If we click on that, we will see that we can create a subscription. And this will bring us to a new screen where we can create an event grid subscription. Cost center, for example. So here we have to define a topic, and the topic will be a subscription. So the subscription that we have used and created the managed identity for. Here you can filter if you want for event types. We are going to leave them all, but In fact, we only need resource write success in this case, because when something has been written to the Azure subscription, for example, a resource group is created, then my function will trigger. So we just click on create. And then it will create the event grid subscription for us. And now comes the beauty, because the big advantage here is that you can use or run PowerShell core and the AZ module in a function app. So when you create a new PowerShell function project, the dependency management is enabled by default, and it has the Azure AZ module included. So that's very nice. And you can also load modules automatically, and you can control the major version upgrade, if you will. In our next demo, we will run some PowerShell scripts that add some tags to resources. Okay, so now that our event grid subscription is created, we will go back to the editor and have a look at our run.ps1 file. So here you can see some basic code that will just output a string, but I have done some homework and I've created a simple PowerShell script that have two parameters. So I have my cost center for development and for production. Those are just two codes. And when a resource group, it will get the resource group ID, and then based on that, it will ask for the tags. And if there is a tag environment, it will look for or development or production. If it finds one or the other, it will add a cost center based on the development or production cost center value. That's it. We just click on save. As you can see here in this code, the PowerShell AZ module, AZ commandlets are used. So you can have the get and the set AZ resource group. And for that, behind the scenes, there are some extra files that you need to change based on the app service plan. So if we have a look at our app service plan and we go to app files, we can see that there are other files besides the run.ps1 that are getting loaded for your function to run. So here you have the requirements.psd1 file. So if you want to use the AZ module in your function app, you have to uncomment this file. So here you are sure that the AZ modules are being loaded when your function will run. One other thing you have to know is that in the host.json file, the managed dependency has to be enabled, so it will download the modules that it needs to run your function from the PowerShell gallery. So once you have saved that and for sure uncommented this line, we can go back to our function, go back to our code, we can open our log window again. So be sure if you have changed the parameter files that you restart your function app to load in the new parameters. And then we can create a new resource group. And what we can see after a couple of seconds is that our cost center tag has been applied to the resource group. So with the support of PowerShell in Azure Functions, we have a lot of opportunities for serverless automation tasks in production. We can now take advantage of the event-driven programming model for example, infrastructure management, but also for scripting tasks across Azure and hybrid environments. Other advantages are that you can have your code checked into source control, that you can enable monitoring and insights, and that you can use Azure DevOps or GitHub for your deployment. So with that, I want to thank you for watching and see you next time. Bye.